A light is on top of a 12 feet tall pole and a 5 feet 6 inches person is walking away from the pole at a rate of 2 feet per second. At what rate is the tip of the shadow moving away from the pole when the person is 25 feet from the pole? So in this problem, we are just going to find what rate is the tip of the shadow moving away from the pole. So to solve that, first we have to look at this illustration. So in this one, we have here the pole and the person. So the first thing we should do is we should substitute the given values in the to our illustration right here. So our given first is 12 feet tall pole. So we can input here. And for our person, it is 5 feet 6 inches. So first, before we input it here, we first need to convert the 6 inches. So we know that 12 inches is equals to 1 feet. So 6 feet is a half of a foot. So we can, so with that, we can say that 5 feet 6 inches is equals to 5.5 feet. So we can input the value here. So now we have the values put in the illustration right here. So first we need to know the distances between the elements. So first we have here the x. The x represents the distance from the pole to the person. Then the s represents the distance from the person to the tip of the shadow. And the L represents the pole to the tip of the shadow of the person. So now what we are going to do next. So in this one, as you can see, we have two triangles that we can see. So let me draw it first. The first is the bigger triangle. We have it 12, and we have at the bottom x plus s, and we have here the angle. And the smaller triangle is from the person, which is 5.5. Here's the angle, and we have here s. So since we know that it is similar triangles and it has the same angle here at the tip, so we can use the formula SOHCAHTOA. So in this one, we know that tangent, the angle of tangent is equals to opposite over adjacent. So in this one, we are just going to substitute the values. So for our first triangle, the bigger triangle, we have here tan is equals to 12, which is the opposite over x plus s. And for the smaller triangle, we have tan is equals to 5.5 over s. So as I have said earlier, these are similar triangles but different in sizes. So with that, since both equations are equal, we can combine them into one. So it would be 12 over x plus s equals to 5.5 over s. Now that we have this equation, we can do cross multiplication. So this would be 12s equals to 5.5 x plus s. And after this one, we can distribute the 5.5. So 12s equals to 5.5x plus 5.5s. And now we are just going to move this value right here. We're just going to transpose it to the other side. So after simplifying it, we will come up with a result 6.5s is equals to 5.5x. So now that we have simplified this equation, the thing that we are going to do next is to differentiate the equation based on time, since that's what we are talking about in this topic in this topic, which is related rate. So we are going to differentiate it based on time. So this would be d over dt. So now if we have differentiated it, we would come up with 6.5s times 1 ds over dt. And for the right side, we have 5.5 times 1 dx dt. So as we have known in the example, the rate 2 feet per second is the distance from the pole to the person. So it is given 2 feet per second. So we know that dx over dt is equals to 2 feet per second. Now that we have that value, we can just substitute it in our equation. It would be 6.5 ds dt equals to 5.5 2 feet per second. We're just going to substitute 2. So to get the ds dt, we are just going to divide both sides by 6.5. So our result, our dsdt would be 11 over 6.5. So we're just going to multiply it into 2 over 2. So it would become a whole number. dsdt equals to 22 over 13 feet per second. So this would be our dsdt, but this is still not the thing that we are looking for. So if you remember right here, we now have the dx dt and ds dt. So to solve for the rate of the tip of the shadow moving away from the pole, we now need to use this unit right here, which is the L. So to achieve that, we are just going to use this formula again, but this time we are just going to, instead of x plus s, we are just going to use L. So writing that, this would be 12 over L is equals to 5.5 over S. So again, we are just going to cross multiply. Now that we're done, again, we are just going to differentiate based on time. So after that, we would come up with 12 ds dt, and it would be 5.5 dl over dt. So since we have already solved for the value of ds dt, we're just going to substitute. So it would be 12 times 22 over 13 equals to 5.5 dl dt. So now, to get the value of dl dt, we are just going to divide both sides by 5.5. So rewriting it, it would be, our equation would look like this. dl dt is equals to 12 times 22 over 13 times 5.5. So now we are just going to input the values in our calculator. So our final answer would be dl dt is equals to 48 over 13 feet per second.